Good evening, everyone. Welcome to these lectures today for the AICTE sponsored SSC organized online FDP on generative AI fluency. So I'll just take your questions for the first few minutes. I would so there were three questions that are coming again and again. One is on where to find the course, and second is the assessment and the coupon code. So I'll tell you that the coupon code, please do not use it right now. You will be able to use it on Saturday. So please do not try to use the coupon code just now. If you're using it, if you have completed the course and you are not able to use the coupon code, please send me a screenshot at kamna@nascom.in. I can put I will put this in the chat so that I'll just put this in the chat. 1 second. We are working with AICT to update your attendance on AI on Atal portal. So if it is not updated, please do not worry. We will let you know once it is updated. You need to complete the course before using the coupon code. Coupon code is valid till November 30th. And please email me the screenshot if coupon code is not working after completing the course. So these are some instructions. I'm just putting these instructions in the chat box for everyone. If you have any questions regarding this, please do not interrupt during the lecture. Uh, uh, I'm just going to now share the screen to show you how to take the how to find the course. I'm just doing that now. Just give me a minute. So I'm sharing my screen. I hope you can see my screen. So we go to Future Skills Prime. This is the website. Once we go on Future Skills Prime, this will open up. Here, you can log into this Future Skills Prime. So I am already having a account, so I will log in. Once you log in, you go here to learning. Here you go on digital learning, and the last tab is generative AI fluency. So you can go here. This is the course where you need to get started. So this is the course part of it. Once you complete the course, then you go here, you type generative AI fluency assessment. So it will show you the assessment. This is the assessment you can see. This you will do only after you complete the course. Now there is one 600 rupees that you need to pay. You need to pay. You need to only apply coupon code. I will share the coupon code also in the chat. Just now I will share, and you'll be able to use it. But if you're not able to use it, please send me a screenshot on my email ID. So I'm just going on chat now. I'm stopping the share. Yeah, your coupon code is GIF 100. If you are not able to use this after completing the course, please send me a screenshot. Please send me a screenshot on kamna@nascom.in. And I'll request you that when the session is going on, please focus on the session. Your lecture will help you to understand the topic in detail and also help you when you are taking the assessment finally. And uh, with the please engage with the lecture. Please give your full focus on this lecture. And I think I am getting one more reply. Coupon code is not there. Okay. Coupon code I have just put in in the chat. One second. Madam Farisa has shared the coupon code issue. I'm just seeing the mail. Okay. Right. So if others are also not able to, please, Ramesh Shanmugamji, kindly send me a screenshot on this email ID which I have shared in the chat. I'll request you to share me the screenshot, so I will get it resolved. In the meantime, please focus on the lecture and request everyone to please send me a screenshot if the coupon code is not working. With that, I'll hand it over to Dr. Prakash. He's the trainer from yesterday. And just a brief introduction. He's a experienced a master trainer in generative AI. He's currently with TechM, where he works on the latest technologies to build complex, to find solutions to complex problems. And his lectures are most awaited and very hands on. So, I will request you all to engage and interact and learn as much as possible from Dr. Prakash Kotetti. It's an
Yes.
honor for us to have him with us. And please make use of this opportunity. Thank you so much. I'll hand it over to you now, Dr. Prakash.
Thanks, Kamala. Thank you so much for the opportunity. Good evening, everyone. Today we will continue our discussion on generative AI applications and use cases. In the previous session, we discussed about how generative AI can be used in filmmaking or content creation pertaining to films, and also we looked at hospitality as a couple of use cases, right? So then we learned that uh, generative AI essentially is one of the specialized discipline from artificial intelligence at scale. So today we'll be looking at few other use cases of generative AI. So let me just start. So today we'll be discussing about, let me share my screen. Uh, Generative AI in music and movie industry, right? This is our topic. I'm just sharing my screen. Let me know if you are able to see this. Yeah, can you see my screen?
Yes, sir, it's visible.
Good, thanks. So we will begin with generative AI architecture and models, and subsequently we will look at how Gemini can be used for music generation, and then we'll look at intricacies of how exactly model training happens. Uh, with respect to model training, we also look into the aspects of data and representation of the data, entire life cycle of these generative AI aspects pertaining to music. And then we try to understand some of the key elements of music as fundamental concepts of music. From there, we will try to correlate how generative models work and how they can be leveraged for construction of music, right? So these are the few aspects that we'll be discussing today, right? So let me just start. We started with the generative AI architecture, right? Let me begin with the same thing. So when you look at generative AI architecture, essentially you started with representation of data, right? So the representation of data essentially means conversion of your data into numeric form. We call it as input vectors, right? So these input vectors will be fed to generative model, The generative model will generate some instance or what we call example. That example will correlate with real life example and see how close they are, right? Because the ability of the generative model to mimic real data, right? Because you are creating synthetic data, right? That should be of good quality. What the measure of that quality? You want to see that how close it is to the real data. So that's where you are using again a discriminative model. So a discriminative model will is like a classifier, and then you actually try to minimize this what we call loss between real example features versus the generative example features, right? This how it works. So yesterday I explained about discriminative model, right? Can anyone just share what is a discriminative model? What is generative model? What is discriminative model? We discussed the difference yesterday, right? Hello?
Hello,
No,
I think
I am
please answer
asking,
in the chat.
I am
Huh.
asking, I am looking at the chat also.
Uh.
So, what is the fundamental difference between a generative model and a discriminative model? I explained yesterday, right? See, let me repeat. A discriminative model is given by, no, we are not actually getting into whether it is fake image or real image and all that. That is only a specific example. But as a model, we need to understand the difference, right? So if you recall, let me just repeat from there, because if we don't understand that concept, right, then we'll have a problem. So I explained you that you define a mathematical function, right? Y is equal to f of x kind of a thing. And based on the equation, you will say that if that data point is above the equation or below the equation, you classify that data point accordingly, whether it is of class 1 or class 0, right? That is your discriminative model. On the other hand, generative models are probabilistic in nature, and they follow derived distributions. When you talk about data distributions, you need to have distribution parameters, right? What are the distribution parameters for normal distribution? Mu and sigma. That's what we said, right? So given a mu and sigma, you can always generate new data point within that distribution, right? So that's what we need to keep in mind in the context of discriminative models, right? Sorry, generative models. Okay. So this is what we discussed. We also touched upon classification of these generative models, right? One is a density based model and an approximation model, right? These are all various types of models we talked about. And we also have autoregressive models and flow based models. We discussed yesterday autoregressive and flow based. I will show you nice uh, uh, blog actually. Let me share my screen. Yeah, yes. Hope you are able to see my screen, right? So this is a good introduction to uh, what is generative adversarial network, right? Or GANs we call it, right? So if you see the architecture of GANs, right, it is similar to what we see here in the block diagram in the slide, right? So what you have here is you have a random input which you give to the generator, and generator will create a content which is, let's say, fake image. For example, in this case, this fake image is given to your discriminator model, and you have a real image and fake image. Both images you are giving to it, right? And then our discriminator model will classify it whether it is a real or fake, right? So you wanted to make these images that that you are generating is as good as your real images. That's what you want to fine tune this model. That's your quality measure, right? So like I said, right, you define a loss function something like this, where you have a generative sample from random noise thing, and you have a discriminator function, something like this, right? So I don't want to get into math part of it because uh, that is very straightforward, right? So let me tell you the intuition behind this uh, math, right? See, for example, let me just share this. So what we are saying here is, just a minute. So you define a model, something like, you know, as I told you, these are all probabilistic models, right? So you define a probability like the concept of generative model, right? So any model, it defines a hypothesis, right? So you simply say probability of defining an hypothesis given data. You simply say that if P is some probability, and you write P to the power of X into 1 minus P to the power of 1 minus X. Now assume that X can take only two values, 0 and 1, right? So probability that X is equal to 1 will be that P to the power of 1 into 1 minus P to the power of 1 minus 1. So that is equal to P. So P is the probability that a uh, particular image, this indicates the probability that you are able to see my screen, right?
Yes, we are able to see your screen.
So particular image is classified as real. That is P of X is equal to 1. Now what is the probability that X is equal to 0 indicates? This indicates the probability that a particular image is classified as fake. Given an image, it can be either real or it can be a fake, right? It cannot be both, isn't it? So if P is the probability that a given image is real, then this represents 1 minus P. Now I can combine these two using this particular distribution function. HD is equal to P power X into 1 minus P power 1 minus X, where small x is a random variable value, right? Where you define this is your random variable, right? So that's where, if you see your last function, right, you must have seen that, right, in the uh, web page, you see something like log P plus 1 minus X log 1 minus P. So it is essentially in this form. Now since the P is fractional value, you want this quantity to be positive definite, you introduce extra minus sign here. Okay. So that's what exactly you can see in the page that I shared with you, right? You can You can check that page also, right? So if I want to share that page, see here. Now you see here log p 1 minus p into log 1 minus p. So it is actually derived from that kind of understanding. And these are all expectation values and other things. This you don't worry about, but intuitively, this is what it is. Okay. So I don't want to get into the math part of it again, but it is very important that you try to correlate with the equation that I just explained. You define a latent random variable like capital X I explained you, and you have a data generator and you have a discriminator which will tell you whether it is fake or real, right? So what does the generator does initially, right? So the generator will start with a random noise vector, a sequence of numbers, right? And it uses this noise as starting point to create fake data. That's the first step. Now, what discriminator does? It is a classifier. What it does? The discriminator D's job is to analyze it and you classify whether it is 0 or 1. I just explained to you, right? The probability distribution function where capital X is equal to 0 or capital X is equal to 1. So, where is adversarial learning? If the discriminator correctly classifies, then it is fine. Otherwise, if the generator fools the discriminator by creating realistic fake data, it receives positive update and the discriminator is penalized for making wrong decision. So it is the concept of penalty is coming from reinforcement learning. We should not get into all that, but overall understanding of this particular architecture is very important, right? So that's why I shared that with you. Now, there are multiple types we have for the generative adversarial networks. So, this much is enough for our subject. So, I just want to continue from here. Let me share the slide. Yeah, right. All right. So, once we understand the fundamental principle behind these generative models, now next thing is how does Gemini work, right? So, what is Gemini AI? Gemini AI is a chatbot tool designed by Google 1 minute, to simulate human conversations using NLP, natural language processing, and machine learning techniques. We cannot separate machine learning algorithms from, uh, even with generative problems, because when you develop a generative AI application internally, you might want to leverage some of these machine learning models, right? So that's why it's important for us to have good understanding and conceptual knowledge about NLP, natural language processing, and machine learning, right? But beyond certain point, we will not be able to discuss these things, right? So fundamental thing in model development is understanding the life cycle, right? What is life cycle in AI? AI life cycle follows something similar to your software development life cycle. So let me ask this question: what are the phases of software development life cycle? Can you just articulate? What are the phases of software development life cycle? Hello? No, no, I want all the steps. I want all the steps. Suppose you ask your student, explain the steps of software development life cycle. What answer you expect? You just write down here. Simple. You can put some small arrow mark, right? Because it is sequential, right? Like Venkata said that it is analysis. Pallavi said it is design. Yes, correct, madam. Analysis, design, coding, testing, and maintenance. Coding comes as implementation or coding doesn't matter. And another important thing is to be incorporated in this, that is deployment, right? Correct. So that's where ML ops or AI ops comes into picture, right? Nowadays, all of you must be hearing this buzzword, right? What is AI ops or ML ops? When you follow development life cycle, you need to deploy your solution, isn't it, in production environment. So in our case, suppose when you develop a generative AI solution, it has to go and sit into the actual environment so that it can respond. Like if you take a bank application, right? Now assume that you have developed a bank bot, right, for customer interaction. Now, when you deploy this bot, how this bot will respond? You have a front end, some web page, and below this bot will pop up and say that I am so and so. Please fire your query here. So you type your input. It will fetch the documents and internal processes and respond to you in a more relevant manner, because that is the ability of the bot. If the bot is not able to respond in a relevant way, essentially what does it mean? Your bot is not doing its job, right? So that's where the ability and interoperability of your application with respect to rest of the development pipeline is very critical, right? So coming back to Gemini, so it is a predominantly kind of a chatbot tool which is for conversational AI. So Gemini is integrated into websites, messaging platforms, or applications to provide realistic and natural responses for user queries. Now imagine how effective this Gemini is. Is there anyone who is tracking this Gemini from, let us say, maybe 4 months or 3 months? What are your observations? What are your observations working with Gemini? Hello? Did you try experimenting with Gemini? Yes, very good. What do you notice? You see significant improvement in terms of the quality of responses that you are getting, right? Compared to earlier, right? Because when you are giving these prompts, when it is responding to your prompts, right, it also internally learns. So the prompts that you are giving, they are also becoming a kind of data on which it can get trained. It is learning from the environment, right? So very good. Latex support, fantastic. So this is a classic example. Latex support is a classic example where you want to generate some equations for your scientific paper publishing, right? So earlier we used to struggle with syntax. Like if you want to type an equation in latex, it is something like slash left then over, like that. If you want to define a fraction, right? All that you don't have to remember now, right? So so is the case with coding also. Another interesting use case with Gemini is it can generate excellent code. given the scenario and sample code snippet to it, right? But when I say coding as an example, it is not that you take some primitive operations like calculating sum of n integers and all that, right? You take some real application, um, you know, something like you want to work with some document automation, right? Using Pythons, right? You must have developed some functions. You must have already had some scripts. Then you give some dependency functions, copy your code, paste it in Gemini and say that, see, I'm getting an error when I'm trying to implement this particular function, then automatically it will give some recommendations, which is very, very, consistent with the semantics of what you have actually developed. So that's how it actually uh, learns from the code that you have written, right? So that's how it is. All right. So now our focus is on not coding. Our focus is on music, right? So we need to confine to that subject line, right? So very good. Now, when you look at Gemini, it is family of multi-modal AI. What is multi-modal AI? Can anyone just put in the chat? What is multi-modal AI? Don't type this question in chat GPT or Gemini. You answer on your own. What is multi-modal AI? Multi-modes, right? Multi-modes means what are the modes? You remember yesterday I explained in the fundamentals data representation, right? Data representation, structured, semi-structured, unstructured, all that I explained to you, right? So multi-modal means video, text, audio, combination of these inputs is called multimodal. So Gemini is multimodal large language model which is capable of processing text, audio, video, right? So since it has the ability to process text, audio and video and generate new text and audio and video, then we want to leverage this for music and composition as a special use case, right? That is where we want to see how it can be used for synthetic music construction and let's say audio creation, right? So this is brief history of Gemini. It is introduced 2023 and it is an arm from DeepMind. And after that, later on, you also see extended version of it, right? Now we are talking about Gemini 2.x, correct? But if you look at these generative models, right? What is the first primary disruption in this generative model? That is Chat GPT, right? Because everybody actually got got a hook onto Chat GPT. After that, Gemini has become very prominent, especially in the context of multimodal space. I will discuss those details, short while from now. Now look at the comparative study of these models, right? And this comparative study is based on various features and various transformer model, right? Pre-trained transformer model, GPTs, right? And Gemini. Now, if you look at multimodal core, right? So in GPT-4, you have a text-based model. You can add that. Then Gemini by design, it supports multimodal characteristics. Now, as a next step, if you want to do comprehension of image and video, right? Then GPT models, they can analyze and describe. In addition, Gemini, what it does, it can also answer questions based on what you are giving. That is, it can describe images, it can analyze videos, and it can also comprehend collective collective inferencing between these, that is something. Now, when it comes to audio understanding, GPT is limited to audio processing, and whereas in this case, it will process, let's say, spoken English. Now, let us say, yeah, in fact, you can also think of a language translators as well, right? Now, if you look at real-time data fusion, then it's slightly not suitable for that. Whereas Gemini, it has been developed in a very very natural way, incorporating these features of multimodal aspects. So it has the ability to combine text, image, audio, video in a real time, right? Because our focus is on how can we use Gemini for music and this kind of video content generation. That is the topic that we are talking about. That's why our focus is centered around GeminiI, right? Now, creative content, it is primarily text based in the case of pre-trained transformer models, whereas in the case of Gemini, it can work with various types of data, which is sound, image, and video. Now, of course, educational research, it is strong for text-based learning, better for interactive and visual experiences, right? All right. Is this clear? Now let us compare this Gemini with OpenAI ChatGPT. Right? Now you can see the parameters. What do you mean by parameter? Yesterday I explained to you, right? What are the parameters in our models? Can anyone type in the chat box? What are the parameters? Fantastic. Weights, right? Because we are talking about large language models where you deal with complex neural networks, and the network and is associated is made up of layers. Each layer is made up of nodes. Now the data transfer from one layer to another layer, right, will essentially facilitates learning higher order features, right? When I say learning higher order features, suppose you have some animal or some bird like like you know parrot, let us say, right? Now there could be other family of birds which will have their beak which is similar to the parrot, right? But unless you have the model with the ability to resolve these higher order features, right? Because for a human eye, the bird with similar beak like parrot, by just looking at the beak, you cannot classify whether it is parrot or some other thing, right? But these models will have the ability to effectively and accurately classify uh, these images, right? How that ability comes to these models? This ability comes to these models because you have a layered architecture, right? Suppose you have multiple layers, right? As you move inside deep into your network, the model will have the ability to learn more and more complicated features. Let us say if you take the same beak, sometimes there may be small dot somewhere on the beak, which can be a clear differentiator between one class of bird with another class of bird, right? Like for example, parrot with something else. Now, if you look at this particular higher order features which are complex, you need to go deep inside your network. That means your model complexity is increasing. As you increase number of layers, within the layer number of nodes, your model complexity increases because the number of weights associated with these edges of your network will be predominantly higher. They will be exponentially higher, right? That's what we are talking about here: 175 billion parameters, 200 billion parameters, etc., right? So that's what complexity all about. Now, in terms of complexity, let me ask a question. Uh, Suppose I develop very complex model, right? Now, do you think it works fairly better where my data complexity is, I have very lower order features in my data? To figure out lower order features, do you need high complex model? Suppose I don't want to recognize face. I just want to see whether human or not. That means I need to just need the contour of the person, right? The contour of the person, if I can just figure it out, that is a very, very low order feature for a image, right? I want to see whether it is, instead of saying whether it is a parrot or some other bird, if I simply say whether it is a bird or a human face, then you don't need that much complex model. Why? Because you are just looking at the contour of that facial boundary. So facial boundary is a lower order feature. Now, if you want to recognize some ornament near the nose, then it is higher order feature. Then you need more deep layers. So the complexity is something connected with the ability of your model to extract higher order features. That's what you need to understand in terms of model complexity. So that's why when you look at this first line, right? Gemini has 200 billion parameters, OpenAI is 175 billion parameters. Can we judge that okay, Gemini is better because it has more billion of parameters? Why does Gemini has so many billions of parameters? What do you think intuitively? Why do you think it has so many parameters? Is it that Gemini is aspiring to do better job than OpenAI ChatGPT or anything else? No, it is not about accurate results. That's what I said. When you talk about accuracy, you should always have a baseline. This is one of the problems in actual real-time implementations, right? Accuracy need not necessarily a measure. Sometimes what happens, even if you have even if you have uh, very good accuracy, still you may not consider that as a better model for your business goal, right? So you need to define your business goal first, because once you define your business goal, even if your accuracy is not good, then you go back and refactor it and saying that okay, the quality of data with which I am dealing is not good enough. No matter how complex model you develop, if the quality of data is not good enough, then you are not going to get good results, right? So that's very important. So accuracy is not necessarily the parameter. What probably you need to look at is the design goal of Gemini. I just explained, right? It is to support multi-modal generative AI development, right? So considering those aspects, you need to deal with higher order features, unstructured data. So that is the reason you have more complex architectures, right? That is the reason you have more billions of parameters, isn't it? Now next comes modality, right? I already explained about modality. Let us look at performance wise. So performance wise, how do you look at performance of Gemini and ChatGPT? Gemini outperforms human experts, multimodal perspective, whereas ChatGPT is comparable, better in storytelling and dialogue. That is text-based scenarios. ChatGPT is better, but multimodal context Gemini is better. Right, Doctor Rahini, you are saying ChatGPT is best because the day-to-day experience that you are having is simple text, isn't it? Correct. So, and that is the so is the case with GPT also. There are millions and millions of people typing the prompts in ChatGPT through which it is learning from the text. Yeah, of course, yes. Because any complex ability of the model comes with some cost, right? That's what in computer science we talk about space complexity and time complexity, right? If you want to have more complex model, then obviously it will require more execution time, isn't it? Yeah. Now let us look at accessibility. Accessibility more or less it is same. Okay, I don't think much significance difference is there. Personally, I feel cost wise, cost effective in terms of their competitors, whereas ChatGPT is a little expensive. So these are the some of the comparisons as of now. Actually, these are continuously evolving, isn't it? So the same dashboard that you see may not be static after 1 month or 2 months. So that is one thing we need to keep it as a disclaimer, right? Now I have some questions for you. Can I ask some questions? Review questions? Yeah, because all of you will be having this exam back of your mind, isn't it? So let us see here. Gemini does not take the support of OCR to understand and recognize images. Try to understand the question. Does not take the support of OCR. OCR is a different ability, right? So OCR is the additional capability that you are supplementing. So do you think that capability is needed? That's how we need to understand the question. Yeah, because of multimodal, it doesn't require this special add-on, right? Now let us look at the next question. Out of three variants of Gemini, which variant has Nimble, a model optimized for mobile devices? Anis Ahmad, you are asking me a question where somebody explains about Ramayana and finally they will ask the relationship between Rama and Sita. Exactly, your question looks like that. I just now explained the difference between uh, transformer models and Gemini, right? The previous slides, that's what I explained, na? Because this is about multimodal functionality. That's the critical difference. Now let us come back to this question. First of all, let us understand the question. What it says, which variant has a nimble AI model optimized for mobile devices? So assume that you want to deploy a generative model on mobile device. What are the key characteristics you want to see on mobile device? What are the key characteristics you want to see? It should be simple, right? Portable. So that's why it should be smaller one. So as the name suggests, Gemini Nano. So sometimes you may have to guess the options also, right? So that is the reason this question is discussed here. Is it clear? Gemini Nano. Now let us look at this. Gemini can be used for creative writing and scientific research. However, it cannot be used in education due to its lack of imparting personalized learning experience. Is this statement correct? False. Gaurav Agarwal says it is false. Satyabrata also said it is false. Can you explain why it is false? Can you justify? Yeah, it can be used. It can be used. And what is the reason it is suggested? Due to lack of imparting personalized learning experience. So sometimes na you may get a question where it cannot be used. Sometimes it may be true. For example, you might be having a question, it cannot be used, but the because reason might be false. Are you getting? What I'm saying is sometimes in the question, the reason that is given might be wrong. This reasoning might be wrong. Okay. So whichever way, you need to be very, very clear. Now, how does Gemini outperform ChatGPT? What are the two aspects? Based on whatever discussion we had on Gemini, can you identify correct options in this? I will give a hint. Only two options are correct in these four check boxes. What are the two options? What do you think? No, Gemini will not outperform text-based thing, right? I told you already in the class. Coding. I told you code generation, right? So 1 and 4 cost effectiveness, because storytelling and dialogue this comes under scripting. We know that ChatGPT text based applications it works well, right? Yes or no? Hello. So what will be the appropriate options for this? Yeah. So this is all about Gemini, and because Gemini has a tremendous uh, generative capability in multimodal data, we are looking at specific use cases from music and film industry and how this can be leveraged, right? So let me just start with the context of music. So if you look at music representation, right, there are three forms of music that you can see here, right? 1 minute. Three forms of music. One is sheet music, where you will have symbolic representation of the notations, right? And you have audio and then instrumental, correct? So now what is the challenges with respect to data? Since you have three different formats, number one, representation of data. So you should be able to do a lot of pre-processing activity in terms of data representation and the pre-trained models, because the limited annotated data set availability. Now expressiveness, right? Because music also has expressiveness, right? The expressiveness is characterized by different features or elements like raga and swara and all that, right? We'll just touch base on those things. Now vocal complexity, then music structure and the context, because every music note is connected with the context, right? So these models which are tightly bound with context are called sequential models, right? Sequential models, if you look at the current note that you see, is the current note that you see is essentially uh, you know is about what appear earlier, right? Because otherwise you will not have rhythm, isn't it? If you don't have that sequential pattern, isn't it? So that's why it is time series data. You can like it is similar to time series, not exactly. It is like basically you have a frequency and a time. Now defining evaluation metric also another important thing that you should focus on. Now let us look at how do we leverage this generative AI in this case. So the motivational aspects are you wanted to add more creativity to music, and you want to leverage technology to uh, create music, and you want to unify music modalities. That means suppose you have somebody who is having a challenge with a physical challenge, right? And different abled person, right? The person is good, very good in drums, playing drums, but you need somebody who can play uh, let us say flute as a supplementary thing, supplementary mode, and you want to combine them, you want to fuse these two. So you want to use generative AI to generate that flute, music, and you want to combine that with the existing one. So such things are possible, right? Now let us see the complexities involved in that. Now the complexity is predominantly with respect to data representation, right? Yesterday also we talked about data formats, right? So as I said earlier, there are three forms of data that we have in music. One is raw data, another one is sheet music, then instrumental. These are the formats. If you say raw audio data, dot wave format, dot MP3, text grid, vocal or MIDI, etc. Now sheet music, it can be XML format or some other. It can be even just a PDF kind of a thing as well, right? On the other hand, instrumental, these are the file formats that we have. But sometimes what happens if you are a sophisticated music developer with coding experience, you may want to use Python libraries, right? So generating music using Python libraries is something called as spectrograms. Spectrograms are basically used with respect to scripting using Python, right? Of course, you can see other formats here, right? Now let us understand this. Let me know if you are able to see the representation here. Can you hear this? Is it audible? Hello? Let me play again. Why no? Just give me a minute. Let me see volume. Yeah. You are not able to hear this? Hello? Anyone? Okay, okay. So this is essentially, yeah, using earphone, correct. So Dinesh Kumar, can you tell me, can you guess a movie where you see this kind of background score? Just a guess, wild guess. No, no, you need to have a device, then probably you can hear. But when I share this slide, probably you can get this. Unmute. It is embedded in this actually, so no problem. So Dinesh, you heard that, right? You are able to hear, right? So if you see this Bahubali movie, right, there is some BGM, background score music, right, which will continue throughout the movie, isn't it? So yes or no? So essentially, when you look at the representation of this, right, in terms of spectrum, like time versus frequency, right, it appears something like this. Now, on the other hand, you have a representation of this data, something like this. It is amplitude representation, and this is a textual representation. All the type of representations you can see. Now, tell me, for a model to be trained, which representation is more appropriate, right? Which representation? Do you think time and frequency is appropriate, or amplitude is more appropriate? This text one is appropriate. Exactly. That frequency time thing, right? Because the implicit periodicity is internally mapped to your mathematical function, right? Essentially, the models that you are generating, the models can understand the representation if it is mathematical format, isn't it? Or numbers. Of course, you have numbers, but hidden patterns are always mathematics, right? Because when your model is learning and extracting features, and if it is describing features, right? Describing features of a person or anything, any object, how they describe, they will give a complex mathematical representation, isn't it? So that's what it is. Now let me get into the next thing. So now let us look at various steps that we have in music. Okay, let me just write here. So let me just unshare and share again. You can see my whiteboard, right? Yeah. Steps in music generation, let us say. So first thing is, what are the steps? You have a data set. In this case, we have three forms of data. Now this, you want to do some pre-processing, correct? So what is pre-processing involves? It involves quantization of nodes, and you also do normalize what we call pitch, okay, and also called tempo, right, in music. This one pre-processing. Other thing that we can think of is, of course, obviously, you kind of encoding schema that you use, encoding schemes. Typically, these are your pre-processing steps, right? Now, let me go to the next stage in the life cycle. I told you software development life cycle, right? This typical life cycle that you see in this generative uh, content development, right? Then model building you have. right? So where you will use some transformer type models, and you will use sequential models like LSTM. Do you know what is LSTM? What is LSTM model? Yeah, sequential model. Fantastic. What is it? LSTM stands for. You can search in Google and put it here. Long short-term memory. So you see something called memory here, right? So suppose you have a musical note, right? Some pattern like a repeated music. Now this is associated with something pre-context, right? So you need to preserve that pre pattern which is coming before in memory, but you can't store entire sequence which is coming before, right? So you need effective language models, LLMs, right? So this is one concept called long short-term memory. You don't require to remember entire sequence before it. So you need to use different mechanism. That's what LSTM means, right? And now from this, after the model development, you have set of other phases. These are generations. You want to generate the content, right? Right. So it should be in sync, right? It should be in sync with original note. That is one thing. Mm, Then another important thing is you should iteratively predict next note. That is also one more important thing, right? And and of course you need to have here conversion, right? Because you need to have compatibility, right? To appropriate type compatible with your downstream activities to downstream. This is typically how it look like the way you are having you know your life cycle, right? Any question on this? Let me just check. Yeah, let me unshare. So these are the, now let us look at various elements of uh, music, right? So suppose if you look at some Hindustani or Carnatic music, we have components like tala, pitch, and combinatorics and recursion kind of a thing, right? So here we have a repeated structures called fractal structures, right? So recursive swara, which are and the phrases associated with these recursive swara, they cause fractals, right? So there are some other aspects like Karves and Jatis, there is evidence of Fibonacci pattern, right? Suppose I will show you one clip here. Let me just now this clip, there you see Fibonacci sequence. That's what people said. Can you hear this music? You may use some headphones or something.
Not able to hear the music, sir. I think you have to give the
1 minute.
system sound or something.
Yeah, yeah, 1 minute. I already gave this here, right? So let me just do this. So let me put this in the chat box. Can you try this? I shared that link also, right? On the chat. Why link is not there? Give me a minute. Suppose if I click this link, let me try. I'm able to get this link. Why you are not able to get this link? See, I'm able to get this. Of course, there is some ad, but still I'm able to get this. Anyone can play that link? Hello?
I can try. Let me try. Mm. Okay, I'm trying to play this link. I will go. Zoom. 1 second. Share. Share. Okay. Can you hear this?
Yeah. So I shared that link. It will work. Maybe you try later, but uh, it is not that difficult actually. So to figure out how Fibonacci sequence can be used, is being used, not can be, sorry. So similarly, let me just show you. We'll skip this and now let me play some video. Can you hear this? Can you hear this?
Yes, good. I was able to hear.
Yeah, yeah.
Vidya ma'am, are you able to hear this? You can increase the volume a little bit. I can hear, but I think others can. Just increase the volume.
No, my case it is full volume actually. So this is an example of one which form, this form of text representation, right? So I just explained you, right? When you have a different ability, how you can actually complement with generative AI, right? Generating music. So this is what we said, right? How do you actually fuse this into existing music, right? So it is like how robotics can be integrated with a robotic drum. This is right. Now there are other applications also, right? So because considering the time frame that we have, I will just skip these things and I will just show you something very, very interesting. Uh, Let me play this.
Imagine a world where you could talk to an animal. Dolphin Gemma is the first LLM for dolphins. We've leveraged over 40 years of Denise's vocalization research to create this large language model to generate new synthetic dolphin sounds. These sounds will help us to one day hopefully communicate with the dolphins.
And also these bird sounds, right, which is otherwise impossible. They also have the ability to cure certain diseases like uh, Alzheimer disease,
You can share your
autism.
screen. You can share your screen. I think they are saying that they can
One
uh
minute.
share. They can hear the audio.
Uh,
Mr. Mithun is
no, no, I will just share
saying,
the reshare the screen. Give me a minute.
yeah, Mr. Mithun. I think yesterday the Mr. Mithun is saying that yesterday also we were trying. Actually, yesterday the trainer had a problem with their screen. But today there
Mhm.
is no problem. We are able to hear the audio as well
I
as
will just
the.
replay again because it's just 2 minutes video. It should not be a problem.
Yeah, just make it full screen. I hope it'll be better for Mr.
When
Mithun.
I was 12 years old,
Yeah.
I would page through the encyclopedia. I would stop on the whale and dolphin page and I would go, I wonder what is going on in the minds of these animals. Language to me is the ultimate question about intelligence. The thing that we haven't been able to nail without a great tool. How do you decipher another species? The main use of dolphin gemma is to eventually look at their natural language patterns and match it with the underwater video. That's how we really figure out their language if they have it. All right, beautiful day. Woo-hoo! Imagine a world where you could talk to an animal. Dolphin Gemma is the first LLM for dolphins. We've leveraged over 40 years of Denise's vocalization research to create this large language model to generate new synthetic dolphin sounds. These sounds will help us to one day hopefully communicate with the dolphins. Dad shows up at my office one day and he's wearing one of his many wearable computers. I'm like, ooh, this guy's like a techno man, right? I said, well, I do wearable computers. This sounds like a summer project. We'll get this done for you. Here it is 15 years later. We've engineered this Chat Junior device to play our synthetic dolphin sound underwater. Now let's see which one this one is. That is the signature whistle for Denise. So whenever she's approaching the dolphin, she can introduce herself. So what they're doing is they're testing the distance at which the two chat boxes can efficiently recognize our synthetic sounds. All right. We want it to work close to 100% before we take it in with the dolphins. It says dance between getting data and respecting their culture. No, I'm not very ready, so. You did great. The true breakthrough for me with Dolphin Gemma is that I can generate so many of these so quickly. I just scroll through here and do days worth of work with minutes. If we're going to use this open model, people would take advantage of Denise's 40 years worth of research and use it to model for their own
Right.
purposes. Science is most exciting when you find something you're not expecting. You may discover something that you never even thought to look for. And that's the beauty. You don't know what's coming.
Yeah. So this is from Google actually. So we are talking about Gemini, so it can be used for generating this kind of uh, you know musics, right? So again, right, there are a lot of practical things now. If you come back to movie industry, right? One use case is Shankar Mahadevan, right? So and Shankar Mahadevan uses music AI, right? You can check this, and similarly AR Rahman also. So there are many use cases where our musicians and singers, they are leveraging this generative AI, uh, very effectively, right? So with that note, I will stop here.
Uh, I'll request you to share the link in the chat.
Yeah, I'll
I was
share.
able to hear it quite clearly, but Mr. Mithun is saying, I don't know why you can't understand the issue. Our system is in its full volume. Now,
Uh-huh.
now we can see the video with very low volume, which is very difficult to hear and
No,
understand.
I will share that link. Don't worry.
Yeah, yeah, please share it here
Mm.
only for
Yeah. Give
for
me a minute.
everyone.
I will share.
Yeah, somehow it was quite clear for me, so yeah,
Hmm. No, it can happen sometimes, but
yeah.
because of
You
these
can.
challenges, we should not skip these things, right? Otherwise, how do we appreciate this? I know that there are some technical challenges, but we should see how we can eliminate those challenges, isn't it?
Yeah, yeah. If you can just
Yeah, give me a minute. I'm trying to do that.
yeah, if you can send this chat to me, I can share it in WhatsApp also, and I can share it
Mhm.
with everyone on the
Yeah,
Zoom call as well. So
yeah.
we'll share the link. Please bear with us.
Give me a minute. I will just give me a minute. I'm just sharing with you. Just to
Yeah,
see.
yeah,
Give me a minute. Yeah.
yeah.
Me similar because if you type this, you will get.
I
Right.
will just share
I
this
shared
link.
one link.
Yeah,
You can. I will share similarly a lot of because once you know the how it works, it is easy for you, right? You automatically you yourself will get links. So many links you can get, not just this, but in general. Are you able
share
to
it
see
in the.
these links?
I've shared
Ah,
it in the group also.
I'm
There
sharing in
you
the
go.
chat. Are you able to see?
Yes, yes.
Uh,
After this session is over, if you can send it to me on WhatsApp, my personal WhatsApp, I will share it in the group also.
yeah, yeah, I will do that.
Yeah.
So, okay, then I think I will stop here. If you have questions, I will take now. We have 5 minutes left.
Yes, yes, yes. Please, request everyone to share their questions. We
Hope,
will share, Mr. Umayal. We will just share in chat. There are links. Why aren't you not able to see the links? The links are there in the chat. I'll also share in WhatsApp. Please post your questions now. It's the time for the question answers. If you have any
no, no, it
questions,
is there
please
in the chat. Can you check the chat once?
please
Because the
check
link,
the chat. It's there in the chat.
yeah, in the Zoom chat.
In the Zoom chat, it's there.
Or can you paste these charts again? Maybe some problem from my
Yeah, sure.
end.
No, no. I'm able to see the chats. I'll paste
I think
again.
I should do to everyone. I think maybe. Can you
Oh,
click that everyone and share that again? I,
yeah, 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 yeah. I'm just doing.
I
I'm just
think
doing one.
because you and me are hosts, so we are able to share to each other, but maybe they are not able to see because you
No,
need
no,
to
no, no.
see.
I'm sharing with everyone.
You please
Two,
share.
two links. Two links you have given, right?
No, three, I think.
Okay. Okay.
Yeah, one or two is fine because you will get, sequential links automatically once the people start using those links. That should not be a problem. This is just to understand how these things work, right? There is nothing great about it. But if you just click one or two links, it should be fine. You will get more links on that. Not necessarily exactly the same link, isn't it?
Yeah, yeah. I think you have sent to me only.
Yeah,
That's
yeah.
why. No
But
worries.
you
I've
you
just
can
sent.
send. Good,
Yeah,
good.
yeah. I'm sending to everyone. I'm
Uh,
sending to everyone.
Sorry, it is my bad. I did not realize that I did not check this everyone thing. Sorry for that. I could have done that. Thanks, Dr. Rahini. So hope this is informative. The session.
Any questions?
Any questions I will take.
Okay. Thank you for your patience, everyone, and thank you so much, Dr. Kotetti, for
Thanks.
your
Thanks, Kamana,
sharing
for the
your
opportunity.
insights.
Thank you so much. Nice interacting with the team. Thank you.
Thank you so much, and I just want to reiterate before I welcome Dr. Gopal. Welcome, sir. And
Thank you.
I want to take
Hi,
a couple
sir.
of
Good
minutes.
evening.
Good evening, sir. Thanks. Been listening to some of the lecture. Thanks a lot. Pleasure to join this meet. Yes.
Just for the information of everyone, uh, there is a question from Vidya for Dr. Prakash has left, I think.
Still here.
I'll just I'll allow you to take this question. Just give
Uh,
us a minute. Vidya is asking, she's interested to pursue research in the field of music. Can you please suggest some areas of research in the field of music? That's the
Yeah,
last
maybe
question we are.
that, yeah, that we can see, because that's very big question actually, even the last question. Maybe we can check. Yeah, definitely. Let me think through, and I think, how do we connect with them? You can
So
take.
I am connected with them
Ah,
in WhatsApp.
yeah,
If you
yeah,
will let me know,
yeah,
I
yeah.
will
Sure,
convey the
sure.
things to them.
Thanks.
I'm
Sure,
connected with all the participants.
sure, sure. I
So
will make a note of this. Thank you.
yes, yes. Thank you, Vidya. We'll get back to you. Once sir get back to me, I'll get back to you. I want to just share for everyone that if for some of you the coupon code is working, that is because you have to fill in your details in the onboarding form. So once you fill the onboarding form and complete the course, you will be the coupon code will work for you. So just want to share that. And Mr. Mohammed Kaleem, I want to share with you that attendance is being uploaded. We are still working on it. I have messaged to AICT. We are talking to them. Please allow us a couple of days. We will be able to update the attendance there. Thanks. So I'll now give it to Dr. Gopal to take this forward. Welcome, sir.
Very good. Thank you so much, Kamna. And I suppose I got introduced earlier for the on the first day. I would
Yes.
rather go ahead with my lecture. Let's first start with the proper screen sharing.
Yes. Yes. Thank you so much, sir. Over to you.
Is the screen shared?
Yes. Yes, it
Very
is. You can
good
make it
then.
full screen. You can make it
Yes, I
full
am
screen.
doing it. Is it full screen now?
Yes, it is.
It's a very good topic again to build further on what we started on 27th, 2 3 days back. Again, experience makes me make all the slides in a very defensive manner. There are no special effects in these slides. The reason is very simple. Early days of PowerPoint presentation and sending it to about 80 90 students, we had to look up for some free space on the web. We called it net briefcase. Net briefcase. The communication networks were very slow. Sending even 20 slides was taking ages. Download times at the other end, where the students don't even have access on their machines, rush to the nearest internet cafe and download. Big exercise. But then what we could manage at that time, make limited number of slides, 16 to 20 slides, push it into that net briefcase. One of the class reps will handle the password, make sure that it is there. But then the people are people, the students are students. 15 minutes before the examination is expected to begin, this guy wants to make a quick reference to a particular PPT. It has to connect, it doesn't connect. So some of the students become wise. They wake up a little past midnight on the day of the examination, wake up their parents and say that now it's a time for me to get the PPT. Well, by hook or crook, they'll open some cafe, do some friend's house exercise, get the thing downloaded. The content doesn't download 100% true. The concerns are much the same. We need to understand that certain problems are still remaining in the way we are communicating between any given source and any given destination. So we bank on what is called a channel property and say that we are upright if the communication is true to the channel properties. Everything holds good even today. The fact that AI has come is not really meaning that communication, but a communication that is meant to initiate actions. Are we able to initiate actions at the other end? Is the person or a thing or an object at the other end correct in acting on communication? Difficult questions. But however, the presentations that we are making, all PowerPoint presentations, come using ChatGPT. You just get the correct tool, the content that is being nicely hosted by the future skills. I like that content, though it is not entirely copyrighted by the future skills. It is a good collection of references. I would say reference material. Great reference material is there. Presentations, you can simply click a button and you'll get a PowerPoint presentation. It comes with oddities. We'll have to have 2-3 reviews before it goes out. Both the presentations are not done out of ChatGPT. However, you can make an attempt to use some of the points that I am covering in these presentations, push it as a prompt into a ChatGPT and see how anything that's a presentation generating tool and see how that presentation comes. We see that difference. Small experiment, but it's a very good learning experiment. Very simple. Take about 5 to 6 slides, get 3 prompts out of it, push it into that PowerPoint generator, see how it generates. I claim that though the graphics may be a bit tinkered of existing things picked up from my class notes, teacher's prerogative, quote unquote, is still there. Some edits were there. However, it is done by me. Writing prompts. Therefore, the net essence of this topic is communicated, I hope. The essence of the topic today is to understand what exactly we are ending up and still acknowledging the fact that we are doing somewhat like this. Something is coming, a mixture of books, a mixture of audio, video. There are people, all kinds of people with different levels of concentration, different professions, different walks of life. All of them are seeing it. What exactly is being grasped? Still a question mark. So we are not assuring that all intended actions are happening at the other end. Neither are we telling that what we are communicating is such a fantastic channel modeled by somebody like Shannon. It's just like that. Shannon is like that. So we are still looking at a context where we want to have an assurance on that. That we will talk later. But we need to keep in mind that we are aware of what is happening. We are exploring, we are exploratory, to some extent operational because of the aforesaid narrative, to some extent operational, aiming to become integrated, aiming to become autonomous, aiming to become transformative. But what we have achieved is phenomenally brilliant. It's phenomenally brilliant so far. So we still have to build further. What is the way to build? We keep talking about a method where we have to learn lessons from what we have done so far. 7 decades of progress in AI, the language problem was addressed. We learned very, very stern lessons. It's not merely about the generations of computer languages, which is a typical 2-mark question in many exercises that we do. All teachers tend to have this first generation, second generation, third generation. The next one is the hardware problem. Do we want a high-end machine or can we have a massively parallel architecture? Right now, the massively parallel attempt is doing wonders. It was promising wonders. It is delivering in a manner where all of us can use some simple machines, connect them in some manner, the result is obvious. So we have progressed from in 25 years, the net briefcase is somewhere there, somebody is doing it. It's a more supervised. What is getting into that net briefcase, who is coordinating, everything is supervised. The concerns about the hardware connectivity are now no more talked about, but still we experience the same in the chat. Anyway, it's a fact of life and we'll have to learn to live with it. 3 of the 5 senses that make it a human are not so advanced even today. That's a fact of life. Very good advancements, acoustics, vision. Not so advanced, smell, taste, and touch. This is what we have learned in the earlier one. So where are we today? Artificial intelligence to machine learning to deep learning to generative AI. Within the generative AI, we are looking at NLP as a goal, LLM as a subset of NLP, and ChatGPT a further subset of LLM. The large language model addressed very squarely the way we are looking at language. How are we looking at the language? We are looking at the language like this. An intersection between computer science and linguistics. Even today, we can always be commented on saying that you're neither in computer science nor in linguistics. But we are able to show progress in a way, we are able to interface on this wonderful computational idea, which is taking us so far. It's a car. The machine learning people tell we'll have to extract the features based on some description which we are seeing, then classify it amongst what it fits best, say it's a car or not a car. The deep learning people say that the feature extraction and classification can somehow happen together because there is a training that is happening before. We have somehow found time to train the neural network to recognize a few things faster. Whatever we have trained, it recognizes faster. That's just about the evolution from perception to machine learning to deep learning. That is what is this machine learning to deep learning. After this, we have addressed that language problem, the language model, which is not exactly like this, more classical. You give a row of text, tokenize, clean up the text, parts of speech tagging, parts of speech. I'm not too sure how many of us would still be happy to go back to a Renan Martin grammar to say which is a part, which is the parts of speech. Is it subject verb object or verb subject object? Frankly, engineering is a profession where we said that is not the language which is most useful for us. It is something else. Therefore, we have excused all that. But part of speech tagging, stop words, lemmas, clean text, and ML model. Roughly, everything about natural language which we are doing follows what we have been trying to do with the computer languages. That is, break it into tokens, syntax, semantics. Grammar rules are specified. Here, the grammar rules are in the form of a more generic part of speech. Roughly, that is how we have been tackling natural language. The result is we are looking at dictionaries, glossaries. You construct a dictionary. Within the ambit of that dictionary, within the ambit of a glossary, within the ambit of a classification, we will get a taxonomy that talks about terms, terminologies. You'll quickly get some response. It learns. Like what we do. Dictionary meaning, glossary, definition, classification is done. And then from which we construct some ontology. Ontology tends to be software developer defined, whereas taxonomy is industry defined or you and I define what we want. Either I use an Oxford dictionary or some other dictionary, it's up to me, my choice. Going by the Oxford dictionary, this word means this. Going by the glossary which I chose, this term means this. So that's where we are in that method. We found it very, very limiting. First, none of us are really so serious in adhering to a set of, let's say, classical Renan Martin grammar rules. But it's necessary. We acknowledge that's necessary, but we are not so good. And therefore, we want a flexibility, like just we talk. A child learns, a child thinks. She's not, a given child is not really studying a course on simplified English grammar. Tables of this verb, part, past tense, future tense, present tense. That's not the way we are working with language. Or that way of doing things is more for a formal context. We'll bring that context again later. Right now, we are toying in the present day classical natural language model between taxonomies, ontologies. Ontologies are automatically constructed. Software tells it is possible, it is possible. This kind of relationship is possible. Taxonomies are something specified. What I pick as a dictionary, what I construct as a dictionary. Well, in theory, you don't have to be dependent on only one. You can do multiple things. All that is fine. So there is a classical NLP which was happening like that. In the second spell of AI, a third spell of AI, we are moving over to deep learning. What is the advantage of deep learning? I'm sorry, I don't think this text is so readable. I'll simply tell deep learning, which is trying to mimic the way the neural networks operate on language. You and I are also doing language now. Please don't ask me to classify whatever I am speaking in terms of a strong grammar, in terms of a strong dictionary. I am not so good. Kamna will have to help me out, annotate all this and tell me out. So we have been banking on what is called non-technical edits in some communications. Do we bring that back into this generative AI? Please do think. When we are communication for initiating action, there's a technical part, there's a non-technical part. We want non-technical edit to come in. Expressibility, trainability, generability. So what we have been talking about as high advantages of deep learning is with some a priori training, we are making things more expressive. The output is still the same in many senses. We are still looking for some sentiment. We are still looking for some classification, entity. The methodology is completely different, and deep learning has caught our imagination because there is something close to what you and I do every day. I'm not consulting any grammatical work to find out what exactly I have to do now, what exactly is being spoken by my predecessor speaker, what exactly is happening in the chat. But I do understand I'm very correct in going ahead. Trainability, generalizability are not entirely wrong. But what was our goal? That was not the real goal. Our real goal of NLP was neuro-linguistic programming, which talks about blending all five senses. Today, where are we? We are about hearing, we are about seeing, visual and acoustic. Smell, taste, and touch aren't there. But the human brain requires all the five to understand many things. The way we are contemplating what is called a natural language, neuro linguistic programming. How we communicate with ourselves and each other to achieve our goals is based on all five. But as I said very early upfront in my lecture, just two are highly advanced, sight and hearing. The other three not so advanced. Well, we had a very, very wonderful surprise way back in 1966, the ELIZA. While ELIZA was capable of engaging in discourse, it could not converse with true understanding. It appears that there is a conversation going on, limited, small, simple, ELIZA versus you, a chat is happening. Is something troubling you? Men are all alive. That's my response. What is the connection, do you suppose? It's asking back a question. A typical question and answer, Joseph Weizenbaum created this, saying that Eliza and you can, on a rudimentary equipment, not a fantastic equipment, on a simple, what is called the display, which we were talking about, a POSIX standard virtual terminal 100 compliant display, Eliza and you can have a simple chat. Well, it gives a feeling. It gives a feeling that maybe it is possible, but it is not having a true understanding. It's fun. However, many early users were convinced that Eliza's intelligence and understanding, despite Weizenbaum's insistence to the contrary. Well, we somehow get an impression that the juxtaposition of the terms are making sense to some extent, and we were simply taken aback on the success of this idea, which is very simple to program. Gradually, ever after the term AI got coined in 56, 55, 56, 70 years is what I reckon with. It was 1965, 10 years later, a decade later, we have seen the first chatbot, Eliza chatbot. We wrote, a project was written for an industry sponsored work on writing up a chatbot specific for that particular industry. That also we can do that. How many people entered the chat room, how many are still there, what are the names, how many have joined at what time, some login, some admin, but the chat goes on. Facilitation of a chat, but not automated. Chatbot is introduced, but for limited administrative concerns. Another project. 69, 4 years later, we got perceptrons. 70, first AI conference. To cut the language concern to what exactly has happened, by 1985, we were sending, that's nearly 3 decades after AI came, something called natural language may be possible. So after 20 years, Eliza started paying off on what we can do with natural language. The progress is obvious in this slide, but I'll stop here on that else. 2005, we had a couple of MIT students generating a paper which got accepted in a scientific conference, and it was done, and they got a certificate and presented. But everything is done by automation. A paper can be written, it can be written. That's all is the meaning. Nature has carried a wonderful article, 2021. Hundreds of gibberish papers still lurk in the scientific literature. It's a great idea that they have done. Nature is one of the most reputed magazines. So how do we find out what came back to us from these machines is really actionable? Is it a scientific communication? Is it science communicated? What is it? Or is it action oriented? Is it something which is knowledge so well represented that we can go ahead? You have to find out answers very soon. Somewhere in the middle, we got this 2011. Please go back to this slide. I'm going back to that slide. Watson wins Jeopardy. 2011 was another landmark. What was it for? Watson wins Jeopardy. In February 2011, IBM's supercomputer Watson, the name of the supercomputer was Watson, defeated human champions Ken Jennings and Brad Rutter in a 3-day tournament on a quiz show Jeopardy. Please remember, it ran for 3 full days, 72 hours. So the stress test, the duration test, everything has been done on this particular piece of work. That's IBM supercomputer Watson. Watson won the final score of $77,140. It's not a flash in the pan. It has been tested out with 2 human wizards in quiz, and a victory that showcased advanced capabilities in natural language understanding and opened up new possibilities for AI in various fields. That's what we mean by natural language understanding at speed. Very quickly, we should be able to do that. That's the picture. Very, very famous picture. Watson in the middle, and it raced to $1,200 and it caught the attention. People started investing on time. 72 hours, 3 days. It was there. The other 2 haven't even opened up on the accounts. So it was a fantastic start. That's when people became absolutely serious. As a snapshot. 2017, Google revolutionized text generation. What we are really talking about is a beginning of a generative idea. What is that generative idea? Given certain pieces of text, maybe simple words, maybe simple prompt, what can I generate from a corpus of material, which is, let's say, fully unstructured data? Can be text, it can be images, it can be videos, it can be anything in any form and format. A completely unstructured tons and tons of data is available. A few words or a few sentences have been given. What can come out of it is the question. So they called it generative, but then the idea transformer is due to Google. OpenAI's generative pre-trained transformer, that is the expansion of GPT. It is generative, as I have been discussing. It is pre-trained because I have been telling that neural networks are doing well because there's a possibility of training, a priori training. Then the feature extraction and the classification happen in a manner where we think that's how we do, human beings do. We are not doing feature extraction and then classification and then arriving at a conclusion. We seem to be doing both with some imagery that is there in our minds, a priori. And then we do it. Learning has happened. The idea of neural networks as a mathematical model, which is easy, is so fantastic. OpenAI called it generative pre-trained transformer. It got the ingredients of all the nice things that I have been discussing. Transformer as a concept came from Google, and I was very lucky to have interacted with them somewhere close to 2017. They were in Bangalore. Google Developer Days was was organized in Bangalore. The core teams were there. Always, when we are seeing things happen at the beginning, we have a better grip on what is happening. We are not. I'm thankful to Google Developer Days organizers. Google teams were here. Generative pre-trained transformer, as the name suggests, reposes the transformers. What is this transformer? I'm skipping this slide. Again, we are talking about what is called a transformer, which we will come back. Let me go through this. Transformer is an architecture. Google Transformer is an architecture. What did they do with this architecture? Handwriting, speech, image, reading comprehension, all this can be taken care. 2070, any form and format it comes, the transformer is able to facilitate what is called a way in which all of them can come together, and we are answering what can happen based on a few terms or a sentence that has been given, contrary to what has been happening until then. But again, we should not forget those early lessons. 65 ELIZA, 85 we started talking about natural language, then came 2011 Watson. So Watson is picking up from all these. There's some handwriting thing. You look at any quiz, take a look at any quiz program, we are challenging ourselves in a similar manner. Some imagery. Can you find out who is this? Who is this famous personality? Who said this? What is this thing? They're all in different forms and formats. So Watson did a great model of that entire methodology, but then we are now looking at transformers. 2011, 6 years later, transformers. So NLP is there, we are not disputing, but the LLMs have broken that constraint set, saying that using huge millions of parameters, unlimited computing power, not necessarily from a supercomputer, but from a massively parallel architectures, massive parallel processing, we can do things in a jiffy, provided we have something called a transformer and something called a pre-trained exercise that has already happened on this model. Therefore, while NLP is the goal, LLM is just there. There have been in the field of machine learning a lot of ideas, statistical language models, pre-trained language models, neural language models, transformer language models. But what is captivating our attention today, and rightly so, is a large language model, LLM. That's at number 3. Out of handful of models which are happening till today, even today, over a span of 7 decades, LLM is doing wonderfully well. And it's fantastic. It's doing great. That entire idea of beating out the need for a specific highly advanced hardware or cluster of hardware pieces and a language which is not like, tokenizer, syntax, semantics, break it, parts of speech compared to the existing rule set. No, it is just like what you and I are doing. There is something which is pre-trained and we are going ahead with that. And we are not entirely wrong. But then that's where the caution has to be exercised. Please do understand that it does this much. Is it actionable? Is it called communication on par with what we began to realize as what comes on this channel is reliable, safe, and secure? We are still not there. We still have to understand a few more things. That's where we have to move from what is called, the awareness, and then next level, but then the operational level, still we are there. We'll have to work further. Reinforcement learning, few short and zero shot LLMs, many types of LLMs have come. I would implore all of you to go back to the NASCOM platform for valuable set of references. Task-specific LLMs, multimodal LLMs, instruction-following LLMs, they're all very good. Why are we creating so many types of LLMs? Because we have to be very careful. If it is actionable communication, better use something useful. What we are focusing most of the times are general purpose LLMs. We can have task-specific LLMs. We can have domain-specific LLMs. It depends. But then right now, or as most of the times we are doing in this proficiency course, we are limiting ourselves to general purpose LLMs. So LLMs are here, and we also have what is called the SLM, small language models. What is the concern here? The context. Most important concern is context. Resources, bias, use cases, all the speakers who have been speaking and the course material that is there for you do illustrate use cases, inferences, controls, bias. I'm not going to spend time on it. LLMs are by far very, very attractive in the sense that they are able to show the strengths, knowledge intensive NLP, human language translation, multilingual. Language is not a barrier. You please try the prompts in multiple languages. It's wonderful to do that. Natural language generation, prompt engineering, multidisciplinary model, dialogue and context management, in-context learning, knowledge synthesis. To some extent, we are able to emphasize the need for context, but later on, towards the end of the talk, we will see what is that context. Weaknesses, unstructured input. It can be just like, some random jumble, whatever makes sense in a flash, it is picking up and throwing out a nice essay. Certain things, noise words, it's removing. Inspectability and observability, contextual understanding, handling ambiguity, fine-tuning challenges. What are the threats? Inference latency. Takes time to infer. Inference is not so good even now, and it costs. Security and privacy concerns, hallucinations, alignment, model drift, prompt drift. This drift, phenomenal drift happens. So this is where it is. I simply wanted to hop, skip and jump to this slide because Google's singular contribution has been this architecture, transformer architecture, based on which the generative pre-trained transformer GPT has come out of AI, and it's primarily a chat, like what Eliza started, like what we were talking about, a chat room, chat bot. That's the way it has progressed. However, its potential is phenomenal. It caught the imagination of everybody. So we should understand that this is how it is to be seen in perspective. Output probabilities, output. There's so many outputs possible. Very quickly, the prompt is acting as a guideline for pruning what are all possible. In that sense, it is a context. The prompt that you have given is guiding what are all the output possibilities that can be pruned, thrown away. What is the basis? The prompt that you have given. So somewhere we are looking at it like that. Deep learning models for understanding and generating text. Transformers analyze chunks of data called tokens, whatever it is, learn to predict the next token in a sequence. Music, image, text, others. We have seen some good examples in the earlier lecture. Dr. Prakash was there. Though I haven't joined a bit early, I wished I could have joined half an hour, 40 minutes earlier, but I didn't. But it's something like that. Image, text, music generation. I did see some examples of Shankar Mahadevan's music coming in. So A.R. Rahman's music coming in. It's good. And there are good links that you were sharing. So in theory, what we are talking about is the plurality of transformer models, out of which OpenAI's ChatGPT is scoring very, very heavily. There is no dispute on it. Many models are possible. As we keep talking in academics, all models are wrong. That's the premise. Some models are useful. This is an exceedingly useful model. It's fantastic to think about it. So we have had encoder-based models, Electra, BioBird, FineBird. We had encoder-decoder-based models. We had decoder-based models. So somewhere we'll have to understand that of all the models that have been attempted, the ChatGPT model is something which is most sophisticated. It's a conversational AI built on top of OpenAI's GPT architecture. As a matter of fact, OpenAI gave the GPT architecture, but then they built a nice chat as an illustrative idea and released it. A good application on what they have done on GPT is chatbot, which was there. 65 we had Eliza, 85 we had NLP, 2011 we were talking about Watson, a very specific to quiz, but then these are all very good highlightable case studies. You may argue that in 20, what to say, nearly 30 years, we got only 3 bright spots. That's fine, but they're illustrative. There are many people who took the leads. Great ideas came in. It leverages reinforcement learning from human feedback to improve alignment with human expectations and behavior. 2018 GPT-1, introduced by OpenAI, 117 million parameters. Unbelievable. You see, earlier on when we were talking about 30 parameters model, we required a completely different algorithm called genetic algorithms. Only then we were able to address 30 parameters. It's mind-boggling to think of 117 million parameters. You please go back to our foundations in your own mind. Every variable adds a dimension. If it is 3 variables in a program, we are seeing 3 dimensions. Just about the human mind's native, innate, a simple human mind's native way of imagining that space, 3-dimensional space. If it is 5 variables, it is 5 dimensions. Very difficult to visualize what is that space. 10 variables, 20 variables. Now let's say each variable can become a parameter that is going into the GPT, 117 million parameters. So we are not understanding or working with language like the typical way we are expected to learn. This is the word, this is the letter, this is the word formation, this is the sentence, this is the sentence construct. Who determines the sentence construct? The grammar. We have not adhered to that, but that's a traditional approach which we have taken. But this is yielding what we have been telling is naturally we understand like this, not the way sentence is broken into words into parts of speech. That's not the way we are learning, we are understanding. We are quick to understand. What is it? That's where the puzzle was. This is promising. This may be the way we are understanding language, the human language. However, only with 2 strong senses, acoustics and vision. The smell, taste, and touch, still long way to catch up. Only then we may understand what is that human language. That's still a challenge ahead of us. Showed that generative pre-training followed by task-specific fine-tuning work well. So there is a generative pre-training. It's always there. A fine-tuned work well. And we are now seeing that generative pre-trained transformer. Transformer is a contribution of the Google people where using certain points, say words, keywords that we gave, out of so many possibilities, millions of parameters which we never even imagined. That is something which is fascinating, very difficult for human mind to imagine. In many ways, today we are not daunted by the sheer volume or the modes of data, types of data, multi-model. We are not daunted by it anymore, but what can come out is definitely beyond our imagination because it is multi-parameter. So GPT-1 in 2018, 117 million. 2019, 1.5 billion. Demonstrated coherent paragraph level text generation. Please understand, OpenAI initially withheld full release due to concerns over misuse. Till today, Sam Altman is telling the same. There is no technology that has really made misuse zero. Anything that is learned or to be learned is always having a trial and error as its basis. So before we learn to use, somehow that misuse is inescapable. It is not an intention to misuse, but we want to learn trial and error, trial and error. But then the documentation on the web, the way we are getting traced on the web is indicative of misuse. Whereas what you and I think is trial and error. That's how we learn. The error builds. It builds because it's there. So it was nice, good caution. Sam Altman has been very responsible indicating that GPT-3 2020, 175 billion parameters, capable of translation, summarization, Q&A, and creative writing. APIs released via OpenAI's platform, not necessarily limited to OpenAI. We can keep on writing up our application programming interfaces. GPT 3.5 architecture, fine-tuned, made publicly available 22, and it caught on. November 2022 reached 1 million users. What really triggered this entire exercise today is 2022, November 2022. User-friendly, very nice, but the lessons were learned. We are thankful to OpenAI for withholding, learn the lessons well within their teams on how this potential misuse anticipated can be curbed, tackled. We leave it to them. But the great idea which we are going ahead with. ChatGPT, the popular chatbot from OpenAI, is estimated to have 100 million monthly active users just 2 months after launch, making it the fastest growing consumer application industry. Statistics are in favor, it is scoring well. March 2023, significantly improved reasoning and accuracy, added multimodal text capabilities, introduced ChatGPT Plus subscription for GPT-4 access, code interpreters, web browsing. Now even code can be used, Python code can be used. Turbo and custom GPTs late 2023, GPT-4 Turbo released faster, cheaper, more context aware. More context is coming in, but still the goal of a large context as we go towards that. Some context is seen, but how? By focusing on the prompt. Let's exercise prompt and prompt engineering. So this is what is the progress from the genesis, scaling up, deep learning breakthrough, conversational mastery. See, it's a theory that deep learning will show a fascinating result. GPT-3 established on a huge scale. It's a theory coming alive. Always we have been talking about the same. It's a theory that came alive. Generative conversational mastery. To evaluate the performance of ChatGPT and other language models, a variety of metrics and benchmarks are used. Today, we have a host of metrics. Always, when we look at a multi-dimensionality in different metrics, the numbers speak better. Not a single factor of merit. We cannot live with a single figure of merit as engineers call. We will have multiple figures of merit because we are always communicating what is called accuracy and precision. Why is it necessary? Because we make compromises. Prompt engineering is replete with compromises. Complexity engineering is replete with compromises. Context engineering is replete with compromises. So when we want to project accuracy and precision, a battery of metrics is usually preferred. Single figure of merit, two figures of merit are not likely to take us far. But then engineers are engineers, engineering physical space. You have the physical artifact in front of you to understand what is happening, not in the virtual space. So we are banking on more and more metrics. ChatGPT has been shown to perform well on a variety of benchmarks and has achieved state-of-the-art results on many tasks. Reference-based metrics, reference-free metrics, LLM-based metrics, many more metrics will come. Many more ways because the measuring instruments are becoming more sophisticated. Billion people are using, and we better give them the measuring instruments. Let's not forget, what you cannot measure, you cannot improve. Whatever is the anticipated misuse, whatever is the set of compromises, whichever way we are making, whether it's prompt, context, or the design or the complexity, we need to understand that it must be improved at the earliest. And that's exactly what the early lessons learned are indicating. The learned literature available, you can go back to those early models where the makers of ChatGPT themselves have withheld, saying that we are suspecting, we are expecting, maybe it has a potential misuse. In that sense, there's no technology that can assure you exact usage, exact correct usage. So let's go ahead, approximate historical timeline metric development. The mushrooming of transformer-based LLMs. Transformer is the core architecture with all these LLMs. And how many came? Of which what is scoring very high on a common set of measurements, metrics, performance metrics is ChatGPT. Understandably, it is scoring well. Well done exercise and well cautioned, well anticipated. So, by the teams, the OpenAI people should be congratulated. Google, Meta, OpenAI, Anthropic, Big Science, Huawei, Nvidia, many more will come. Many more will come. Transformer as an architecture is great. Multimodality, everything is promising. But then we have to progress further. The drift phenomena. New research from Stanford and University of California, Berkeley highlights a fundamental challenge in AI development. That's drift. Drift occurs when improving one aspect of complex AI models leads to a decline in performance in other areas. If you have a multi-parameter idea, supporting one parameter may be a contradiction to another parameter, may have conflicting demands on another parameter. How many parameters we are talking about? Billion parameters. In itself, it's a stiff challenge. So what is happening is in such a multi-parameter context, a measuring instrument for accuracy and response rate in itself is a wonder. And we are improving on these instruments. We are getting good battery of metrics, put them together and understand where exactly we are pitching ourselves. ChatGPT has shown deterioration in basic math operations despite advancements in other tasks. Well, it has its weakness. It's not meant for math. We don't chat in mathematics. It's not meant. We don't chat in sigmas, pi's, integrals. Actually, we keep ourselves aloof when we want to talk like that. It's not a chat. But then as the academic interest goes, I always pick that line from that source. ChatGPT has shown deterioration in basic math operations despite advancements in other tasks. There are many other tasks. GPT-4 exhibits reduced responsiveness to chain of thought prompting. Prompt chains, it's not so good. Anyway, always there are pluses, there are minuses. First, we must have a problem to resolve. Easy writing, summarization, translation, information retrieval, invoke APIs, not APIs, APIs, action call, external applications. If we have something like that, a problem, then we have a solution. Then we need to model commercial APIs, Google, OpenAI. The leader is OpenAI. And I'm definitely of the opinion that they have done a wonderful homework on potential misuses, anticipated misuses, but no technology is devoid of misuses. We have to learn it. As we bank on trial and error, as we improvise on the trials, the error generated trickles, percolates, magnifies. We're talking about millions of parameters. It's almost understandable. So therefore, our measuring instruments should become sophisticated. We should impinge on measuring instruments that tell us, using a good set of metrics, accuracy and precision. It's absolutely important. And they're doing a good job. Use of foundational model as it is prompt engineering, fine-tuned, may require specific hardware infrastructure. In this lecture, I am not really talking about hardware. Once again, we go back to the second problem. We addressed two major problems 7 decades back. One is language, the second is hardware. Both are still valid. We still want to do something else. Should we go back to some other fascinating hardware? But then we'll have to look at what can be done. train a model from the scratch. Why don't we train ourselves? Why are we wanting pre-trained? Tomorrow you will ask that same question, sir. What happens if I remove in GPT, if I remove that pre-trained and put my trained model? Imagine, imagine. It is not GPT, it is GMT. That is generative my trained model. What will happen? Transformer architecture is known, it's open. Google fellows have done a great job. Instead of pre-trained, I will have my trained. Chat, generative, my trained model. Can happen. We are not allowing it. OpenAI is not so open. Let's hope tomorrow it will do it. Anyway, train a model from the scratch. You can build it for yourself. But then let's not deviate further. I'm sure I communicated the message. A plethora of open source pre-trained models. There's so many pre-trained models. This slide is not looking so crisp on my screen. Maybe because it's full screen. I'm not wanting to disturb this. Sorry, my apologies. At the moment, it is not looking so crisp on my screen. The problem at hand, if you have a very good problem, you can always build a pre-trained model. So the prerequisite for a pre-trained model is what is the problem that you can think of that requires billion parameters of a language model, multiple, let us say the massively parallel architecture to arrive at a solution. I am racing back to those days when India's first attempt, a mission on supercomputer it's a successful mission. A successful mission, Param was built. Supercomputer is happening. Parallelly, a lot of people are questioning what will anybody do with a supercomputer in 90s? We don't even know what to do with a computer on the desk. The computer on the desk is also not arriving properly. What is the use of a supercomputer? All of us who were running around to do some exercises with it were questioned. So we started talking about weather forecasting, space modeling. Who will need? Then you make one model, one supercomputer, one for weather forecasting. Well, supercomputer succeeded. Today also we have cluster of supercomputers. No dispute on what is happening. We still want the assurance of a verifiable supercomputer model rather than a massively parallel architecture that is probabilistic, inherently probabilistic. The problem at hand, the strength of the model, the operating costs, other considerations, I've listed about 17 of them. My apologies, still not crisp. So based on all this understanding, we are moving to communications. What is the concern with communication? Ideally, it should be safe, secure, and reliable. What is safe? The sender and the receiver know precisely what has been sent across the channel. What is reliable? Both the sender and the receiver knows what is the fate of what has been sent on the channel. Has it been reached? Somebody got stuck somewhere. It is still not yet there. We have to keep communicating. The old world ideas we still bother about ourselves. What is secure? Even if somebody wants to intentionally break, it should be secure. The three words that define communications across any channel, because of these three words, we are using whatever comes on that channel with supreme confidence of what is called information theory. Go ahead and use it. It's true to the channel. If the channel is constructed like this, go ahead and use the information. Been proven, well proven, thanks to Shannon, father of information theory. Whereas what we are looking at communications now is it actionable? How do I know that? The scope of interest, 360 degrees, row frames, encoded, public edge media, the format, the virtual user viewing the scene. Using generative AI, this is what I described. All this is so sophisticated now. A 360 degrees camera, a scene of interest, it's being captured. Will it give me a large context? Big question mark. It is happening. all this sophistication is nicely done as an information theoretical model across a channel. Just 3 words: safe, secure, reliable. So what is happening here towards towards my left hand side, and as you see it, it should be towards your left hand side. It's captured on a scene of interest, 360-degree vision of a camera, multiple cameras, raw frames, encoded, public edge media. All this is governed, defined, controlled, regulated by only 3 words: safe, secure, and reliable. All this is feasible across billions of parameters, across multimodal. That exercise is definitely happening and it's feasible. Use of generative AI for executive communications, senior communication leaders. Gartner is a very valuable, uh, valuable source about. We are currently using generative AI to create executive communication, but they are actionable, but only 16%. Gartner is a uh, worldwide uh, provider of such insights, very respected. 48% we are piloting the use of generative AI to create executive communications. 31%, 5%, we have no plans, 5% no plans. Senior communication leaders, other executive leaders are just about beginning to handle. But 64% of senior communication leaders seem to be going ahead with reasonable degree of assurance and parallel checks and other ways of cross-checking that communications which are actionable are feasible using generative AI. Immersive communications, that you still feel that you are going through. That is what is the expanded imagery of this simple description which I have been talking. A sender, it doesn't matter who the sender is. What is being sent is a scene of interest. What is being visualized is a virtual reality user viewing the 360-degree scene. So it is definitely possible. Some years back, I got a wonderful opportunity to work with the Tamil Nadu handicrafts, uh, uh, handicraft handicrafts Kumpuhar. So what is the goal there? It's becoming very cumbersome to display all the fantastic handicrafts which reflect the culture, which reflect the skill, the traditions of this land called Tamil. It's fantastic to watch those handicrafts, talk to the people who make those handicrafts. Now it is next to impossible to ship so many samples to any showroom. How will they know? Tourists come, tourists go, pan India we can display. And airports, the commercial space is very expensive. Let's talk about airports. The idea was great. It was a practical idea which we wanted to build further, but then within the given time, within the limited resources, we could showcase some progress. But the set of ideas are still there. We should be able to generate more. So we have a library which is showing well captured images of a variety of handicrafts from anywhere. Using virtual reality, you can physically feel those handicrafts in some manner. They get a feel for it. Please understand, it is still hearing, acoustics, and vision dominated. The smell, taste, and touch are still not so advanced. Vision dominated, you have that virtual reality handsets, and then you wear it, handsets, the simple joystick kind of a thing. And in the virtual space, you really think you are playing with those objects, understanding those objects. So suddenly we have a possibility using a limited space, we can show thousands and thousands of handicrafts that are made anywhere, which are the input providers for the Tamil Nadu Handicrafts Association. This is the expanded idea which was envisaged 3 years back. We'll have large language model code generators. People would want to talk like imagine that it is not merely seeing the object, but interacting with a knowledgeable person. As I said, you talk to the person who made the handicraft, then you will know why it is so worthy. It's not the price tag. It is something about the handicraft that should be there. Can we have a large language model? As teachers, we are always licensed to have so many pipeline dreams because we are not doing it for ourselves. We keep telling it is for the 90 people ahead of us who will do much better than us from tomorrow. That's the goal of teaching. So therefore, we have been talking about all these pipeline dreams, LLM code generators, LLM descriptive generators. The ideas were there, but then we have to take it up as a challenge. Now the artifact comes. Imagine that a virtual maker of that handicraft is explaining to you, interacting with you, using an LLM chat, telling that this is the elegance of this handicraft. Then you will understand it better. It's not the price tag, it's about a value that we are talking. Can we build that value? Well, anyway, some pilots have happened. We are very happy that it rolled out, and we had a good team, very good team with the government. Many things have happened. That's something which we talk with the futures. LLM is very promising for that. Then came the presentations. Am I still tracking the time correctly? Still have another half an hour, I suppose. Yes. Presentations. Is generative AI the new PowerPoint? We are not using the term PowerPoint, but you can simply give a few words, take some dominant ideas, keywords or dominant concepts from my presentation, feed it to one of the tools which the course material refers to, and you will see a PowerPoint coming out. So that's how it is. Implementation of an augmentation workforce with generative AI. It's a nice way we started with, which we called computer supported collaborative work. CSCW tools. The chatbot which I described in the beginning, which we did with for a industry, it's a project that we had with an industry. It was an open chat room facility. We will find out who logged in. It was the very rudimentary earlier versions of what became computer supported collaborative work. They called it chat room facility. It blossomed. It became a wonderful tool. CSCW tools, there are many, but then it's a productivity enhancer. Now you add generative AI plugins to that. Automated labor opportunity, low and direct impact generative AI. It's just a sketchy model. Again, it can happen. AI presentation makers for PowerPoint and Google Slides plus AI. Copilot, somebody was talking in one of the lectures where I attended for some time. Copilot is happening, but at the moment, Copilot is very good for taking meeting notes, generating very quickly. By the time the meeting is over, we are having the minutes generated. Generating the minutes has been a task, a big ask in many cases, but then it is generating it with some nice snippets from the presentations made. It generates a report properly. We have done it 2 times now for the Data Spaces Week. Our good friends in Japan, they are very resourceful. Very quickly, the report writing happens. So, well, Slides AI. These are three very important tools. Copilot is very famous, very popular now. Out of the three, one is the Chat GPT and its evolution, emergence that has taught us some very great lessons. There's great literature review, and we are always thankful to the OpenAI for the cautions that have been exercised from time to time. Presentations can be made. We can talk about communications to case studies. Please refer to the course material. Trial out. My idea is to go take you to the next few steps. Proficiency is good. It's nice. But then in the scale of maturity, we are still not yet operational. We are thinking, and rightly so. Presentations, is generative AI the new PowerPoint? Is a question. So we move to this idea called prompts. ChatGPT has happened like this. Large language models, it has its strengths, it has its weaknesses, it has its opportunities, it has its threats. The SWOT analysis is well articulated. What I have presented is a very simple way of talking about SWOT analysis. There are very many papers that have done an in-depth SWOT analysis with with illustrative examples. I am opting to spend more time on the chat GPTs and prompts. Communications, it's understood we can build more, we can integrate many things. The PowerPoint presentations, we can build more. Those two things I am requesting all of you to kindly refer to the future skills material. They are very good narratives, very good use cases. Everything is being spoken. And I'm sure all of you can log in very soon and pick up those ideas. Few slides on those two, many slides. The time distribution for my 90 minutes has a focus on the way we have arrived at this idea using chat GPTs and prompts. They are the most important foundations which we'll have to work on. Prompt is not a new idea. Neither is the context. When we were building systems, we were always talking about context and context switch. When we want to schedule in operating systems, say that this process is taking a lot of time. Why don't we schedule it out? Bring some other process, bring it back again. I don't want to do all that. The operating system should be able to do that. And all that I need to know is a few commands. DOS has commands. Unix has commands. Command is something that was so useful, so nice in many of those early interfaces. A good interface, working interface. At that point, it was great. As I showed in ELISA, using those rudimentary terminals, virtual terminal 100 compliant terminals, we are able to show a dialogue, which is something, which tells us something. Maybe it's indeed a very what to say, interaction between a human and a program, which is making some interesting senses, meanings, purpose is being shown, but very rudimentary. This is 1965, using just commands and a rudimentary interface. So I'm not harping on the fact that we didn't have great input and output devices, but then it was good enough for us. Please learn some commands, use. If you want to use the operating system, benefit from it, please spend some time learning the commands. The load on the memory is very high. DBase showed us a nice idea of assist. Databases were catching on in 90s. DBase 3 Plus was a very popular database, which very quickly gave way to what is called FoxPro. Databases are so fascinating. By that time, the statement that the world revolves around data, no more the sun. The world is revolving around data. Sun is a data. That's how people were talking. It's all revolving around that. Databases in DBase are highly structured, not going to teaching DBase, very structured, and then many operations are supported by a management system. The operations are not so many, but we are always worried. If I ask the database management system DBase 3 to do some exercise, some operation on the database and give me an output, am I using the correct set of commands? The same question you have to ask on the prompt. Prompt is possible, prompt chaining is possible, everything is possible. But are we correct? We were always having that concern because data coming out is actionable. It's like the world revolving around data. And it's actionable. So we punched in this database at the database prompt, DBase 3 prompt, I punched in this command, I got this. Can I go ahead using it? Or a typical illustration is out of 2 million records, when a query came, only 2 records came. Am I sure? Or is the database sure? All questions remain questions. We're not talking about database theory. It's a subject in itself. There were three very important topics that we were banking on outside of computer architecture: operating systems, databases, and networks. Hardware became something, which we can presume. We were not spending much time on the architecture and organization. It somehow became presumable. Three topics: systems, networks, databases. All three are intertwined. Even today, they are intertwined. We'll have to somehow build on that basic foundations. Assist DBase 3 Plus started talking about a special command called assist. Assist, when launched, tells you what do you want to start with. What is your first command? Give the first command. And it will tell these are the options for the next command. Choose one of the options. If you have chosen this option, the next possibilities are only these. The next possibilities are only this. So instead of recalling from memory, this assist will help you construct your query to the database management system step by step, each time prompting you to make a choice. Please choose this, please choose this, please choose this. Since you have chosen this sequence, you are ending up with this result. And the database DBase 3 Plus makers say we are standing by that. It works. GUIs, that revolutionized everything. Today we don't talk CLIs, we don't talk about assist requirements. The GUI is so popular, graphical user interface with simple elements, which all of us know. Almost intuitively, we have a feel for what that machine is asking. We are no more talking about the prompt in that traditional sense of prompt: C prompt, D prompt, E prompt, Unix prompt 1, prompt 2. These are not the way we are talking about. GUIs have revolutionized the way we think about interfaces. Visual programming, how to blend programming to facilitate what we call interaction. Please recall that example that I gave, the artifact, the handicraft. You're interacting with the system to find out more. And usability engineering, this is a sequence: CLIs, assist, V's, visual programming paradigm, and usability engineering. That's a progress which has happened in the last 25 odd years. And we are now doing exceedingly well. User prompts, the generative AI generated response, the knowledge base, conversation history, contextual information, retrieval augmented generation. Is it good enough? The retrieval augmented generation, the retrieval of what is happening, is governed by a conversation history. What I have been doing with it till now. Next is contextual information. Banking on the history, please look at your web browsers. It tells you the history. So next time when you want to type a search context, the web browser will prompt you. Are you wanting to do any of this? In the previous 10 usages of search, you have been talking about such ideas. It comes, it's prompting you. Are you wanting to proceed further? Or imagine a library like what I showed in the first slide, telling that in the last 10 visits, you are only talking about NASCOM, proficiency, AI course, and these topics. Are you wanting me to do better on this, or are you selecting a completely different topic? That's how it is. And you try to chat some of the content which NASCOM is having on its repository are echoed in that content. You can always trace it. It will tell you. If you construct the prompt properly, it will tell you this is appearing in so many places. I'm not talking about a plague check tool, but sophisticated plague check tools, plagiarism check tools, which do much better, wherever it is. The tragedy is even what I wrote will come out like that. It's overlapping text. Conversation history, contextual information, retrieval augmented generation. Again, you go back to the user prompt. You can refine, trial and error, make better prompts. So here, in this last set of slides, the focus shifts from how are you selecting your prompts? Are you selecting your prompts to maximize what the augmented generation is giving in a sequence: generative AI, AI generated response, taking into account conversation history, contextual information, and improving the prompt. A cycle of starting prompt, improvising the prompts till you are completely satisfied. Yes, this is a prompt that I am hunting for. How much of trial and error has happened? In the process, I'm not talking about anything accuracy, precision, but then can you choose better prompts straight away? You have consultants now, prompt consultants. You're talking about how to choose the best prompt straight away, or am I going to experiment? That's the question that we are asking. Why our prompts matter when engaging with ChatGPT? As the likes of ChatGPT have grown in popularity, so too have the discussions about its impact on the workplace. Please understand, about 64% of the communication executives are still finding ChatGPT okay, because they secretly tell, I have a learned workforce. They themselves can decide. If an apple is being called mango, today we are telling them it was junk, something happened, throw it away, some transient error has occurred. I can use my own idea and proceed. As with any new technology, it's likely that new jobs will emerge that capitalize on the new capabilities. With prompt engineer, one that has gained a degree of popularity among commentators. The right prompts. Research from University of South Carolina's Viterbi School of Engineering explores how we can construct prompts that get the right kind of answer, with the paper highlighting the importance of interacting appropriately if we want feedback that is robust and reliable. We demonstrate that even minor prompt variations can change a considerable proportion of predictions. Researchers first looked how asking for responses in different formats affected the results. I want only images. I want only video files. Please search. Please note, on the top of our Google search bar, we'll have take all, image, videos, PowerPoint, so like that. If you restrict the filters, what will be the results that are coming? Effectively, what it is meaning is this cycle. Well, it's a good paper now. It was published very recently. It tells the same, saying that we have a way of tracing these steps. Prompt, generative AI, AI generated response, knowledge database based on conversation history, contextual information, and you get a retrieval augmented generation. Please give me a corpus. We can do this experiment ourselves. And the corpus is worldwide, it can be domain specific. Very quickly, we can learn that. We can learn that intelligence can be built on prompt and improvise. It is something that we have been talking about. So, generative AI prompt principles. Generative AI is not outlandish. It's no different. Garbage in, garbage out. The very old lesson. But what we are using is a prompt is going into an LLM model, large language model, and the response is coming, and we are trying to build this exercise of prompt and response in this cycle. There's a research paper that has worked on this cycle in a limited experiment in University of South Carolina by Viterbi School of Engineering. It's a good paper. They have found out some very interesting, useful results. Context, task, and output. We are still not so good on context. We'll see later. Garbage in, garbage out is still true. You send some junk words into it, a fascinating, literary looking output will come. ZZZ, MMMPPP, something will come out of it, whatever you mean about it. So some exercise will come. We will write something, though not directly found. You try it out. Please go ahead, use it on that. You can experiment with that. You have tomorrow our goal as NASSCOM, AICTE, NASSCOM, FTP, FTP supporters and sponsors are indicating. The goal is to take it to the students. Today we are having 170, 200. Let's say all of them will pass the examination at the end, which Kamna is threatening to administer. In every session, she is saying the same. I'm threatening to administer examination on Saturday. So it's not Saturday evening or Saturday afternoon fever, but it's an examination fever. Let's hope all of you pass, and each one of you is passing it on to 100 students. Then it multiplies. All these are ideas which you can use to learn trial and error. Provide the context in why portion of the prompt what task you need to be done, frame how the output should be provided, brainstorm the AI to ask question for clarification, fine-tune prompt by posting follow-up query. Yes, there are experiments which are being tried out. We tried to build something. The prompt has a structure. Please do a comical play on the lyrics. The format ignores please do. It's not necessary. They are not words that are going to influence Norman Nielsen group. Both Jacob Nielsen and Don Norman have been pioneers in usability engineering 30 years back. Nielsen's group with Sun Microsystems and Don Norman's group, both of them have been champions. They've been around for 3 decades. I use this slide very often. The Norman Nielsen group, we have been talking about these ideas in usability engineering because users come with all grades of expertise. Some are novice users, some are just about beginners, some are reasonably interested but not so much serious, different grades of users, different samples. So a typical case which we are talking about, a lot of people are coming, playing with what? 1.5 to 2 billion parameters on a massively parallel processing power, which gives you the results in a flash. So, and we learn. We are just here to focus on that word learning, deep learning. Deep is something which I spoke of. Learning is a game changer. We are all learners. And therefore, we have to go by these simple ideas to make sure that during the process of learning, we are safe, secure, and always reliable as people, as channels, as machines. Finally, we cannot blame technology. Humans cannot blame technology. Comical play on the lyrics is the format. Format tells just go ahead with comical play on the lyrics. The prompt simply focuses on these words: comical, play, lyrics. Reduces to 3, pushes it into the GPT, generative pre-trained transformer. And it's a chat. It gives you a fantastic text. Not stopping there, it's a big query, please remember. Holy by Justin Bieber. Now we are adding a filter. Please do a comical play on the lyrics of Holy by Justin Bieber. But center the song on Mr. Smith. My dog, he is a cotton. Mr. Smith is a dog. How will you know at this stage? We don't know. He is a cotton detailer, the type of the dog pedigree. His girlfriend is our other dog, Baby Jane, who is a Lhasa Apso. Lhasa Apso. Framing. So how will anybody parse this to understand what is happening? Human mind reads it fast. When written in a nice sentence with not so many boxes and colors. I would rather read, please do a comical play on the lyrics of Holy by Justin Bieber, but center the song on Mr. Smith. My dog, he's a cotton detailer. His girlfriend is our other dog, Baby Jane, who is a Lhasa Apso. So Norman and Nils picked from their good exercises, use cases. First, you look at the format. The format of the prompt guides to what are put in the boxes, different colors. The format directs how to read the reference. Where should it get from? Holy by Justin Bieber. What should it happen? Mr. Smith should come. It should become very clear that Mr. Smith is not a person, it's a dog, and it is also interested in tagging everything to a girlfriend dog. That this much exercise has to be done. Therefore, we tell that the prompt is given like this and it is making sense and it is feasible. You can try it out. 12 most known ChatGPT prompt techniques: direct instruction, role play and simulation, temporal sequence request, multi-turn conversation, specific contextualization. Are the slides visible? Hello? Hello? Very good. So we are coasting on well, and we still have few more minutes left. So let me come back to this presentation again from current slide. There are 12 most known ChatGPT prompt techniques. So what we keep telling is, if you are sticking to these prototypes, these molds of talking about prompts, we know what you are likely to get. Anybody can tell if you are sticking to that. If you want to create your own prompts, your own output, then we'll have to look up for a good basis, learn what is called prompt engineering. We need to do that. 11 best ChatGPT prompts for better results in 2025. Principled instructions are all you need for questioning. Researchers at Avila Lab, Zayed University of AI, they tested 26 different prompting techniques and measured two things that actually matter: how much they improved response quality. Only two figures of merit: response quality and whether they made answers which were factually correct. What's the quality of the response? Is it jazzy? Is it zittered? Is it some jumble? Or is it factually correct? Good exercise. Only 11 best ChatGPT prompts were found. They gave some very good samples picked up from that paper. Avila Lab in Zayed University, Saudi. Human without principles, without any principles of prompt engineering, explain the concept of climate change potential effects on the environment in one short paragraph. The ChatGPT GPT-4 generated this. But then you follow some principles of prompting, you get a better paragraph. We didn't specify how many words, how many lines. Short paragraph. Do you agree that the first one was a short paragraph? Yes, but the quality is much better for the second one. The second out. Slightly better refined prompt. There are many such good examples. One was not helpful at all. ChatGPT generated an utterly useless output. Then there was something which is not so helpful. So we have seen some use cases. It is a fact of life. Whether it is 2025 or whether it was 1940, garbage in, garbage out. But then in ChatGPT, the input, the prompt is not so much appearing to be garbage, but junk may come out. You should be careful about it. So there are application security project that has given top 10 language model applications. Lot of interest has come on LLMs. Everything that goes before the prompt. Prompt engineering should happen before the prompt has. Try, refine, please spend time on what I discussed about what can be a prompt. How much time should go before the prompt? After the prompt, there is only one step. Before the prompt, there are 1, 2, 3, 4, 5, 6 steps. You should do 6 steps before you construct a prompt. That is what we have been advocating. You should do more homework on the prompt. There are automated prompt assistants which take you through that. Prompt engineering, query crafting, limited context, chain of thought, sequence of prompts. There is, yes, Kamna, I'm almost coming to the end. The math word problems are difficult. Because single prompt is not likely to do much better, we have a tendency to chain prompts, but that is also not likely to give great results. The strength of the chain is determined always by the weakest link. So we are talking about prompts, one prompt, two prompt, three prompt, but the weakest prompt is dragging everything down. Even if we are talking only about two figures of merit, the response time and the quality, authenticity of the sources, we'll ask them to give sources authentication. It's giving references now. Look at any chat GPT, it will automatically give you references. How many sources of that are authentic? That we'll have to think. A chain of prompts is not likely to be always better, but we promise. Computation is powerful for processing data and following logical rules. It is inherently bad at handling the dynamic, flexible, and subjective elements of context. Context generation, context engineering, prompt engineering in context are further challenges. The next challenge is not large language model plus great, massively parallel or cluster of supercomputers. It is likely to be a large context and context engineering, the art of providing all context for the task to be plausibly solvable by LLM. Does your prompt communicate instruction, long-term memory, state history, retrieved information, available tools, structured output to get the best result? Still a challenge. Each of you should take it to 100 students and see how good, how best 6 steps before the prompt will give you the best prompt. Formal verification, it's a long haul. We are already short of 3 senses. The goal was neuro-linguistic programming. It is still not there, NLP. So formal verification of what we are doing is something that is requiring a great foundation. And if you can construct a theorem prover, a prover to do that, there is nothing like it. So our good colleagues who are listening to this, who are all teachers, we are definitely exploring in a reasonably well-guided, supervised model with this Future Skills project, AICTE and NASCOM should be thanked. How to go to step 6? Question is open. Thank you very much.
Thank you so much, Dr. Gopal. That was a very, very informative session, like the earlier sessions that you have taken, which you had taken in the last cohort also. And I'll just request you, I think you have updated slides a little
Yes,
bit.
I'll
So if
send
you
it.
can,
Send it.
yes, please share the decks with me. I'll share it with the group. Couple of things, if you guys are still here, I just want to reiterate that some of you have already taken the assessment on Future Skills Prime. That is all that you need to do. For some of you for whom coupon code is not working, it can be 2-3 reasons. One is you have not completed the course. Second is you have not onboarded yourself. There is, so when you go on the course, when you sign up on Future Skills Prime, it asks for certain details like your Aadhaar number, your telephone number, your address. So please give that information only once after you are onboarded, the coupon code will work. Many of you have written to me that coupon code is not working. You need to onboard yourself, which means give your details. You need to complete the course and you need to use the same email ID with which you have registered on the Atal portal, AICT Atal portal, because the coupon code is assigned against that email ID. Only that will get you, that will waive off the assessment fee. So with that, I come to the end of this session. Thank you so much once again, Dr. Gopal.
Thanks.
And I will be sharing a feedback form with all of you on Saturday. So please fill that and then also give your feedback on the Atal portal. So thank you so much, everyone.
I'm sending it
Yes,
to a Gmail
there
account,
will be
Kamna.
a recording which we will post after the cohort is over. All these recordings will be shared on NASCOM's YouTube channel, SSC NASCOM's YouTube channel, which I will put on the WhatsApp group. So you can take it from there. Thank you so much, everyone. We'll see you tomorrow, same time, 6 o'clock. Be there. Okay, bye.